Clean hydrogen is one of the biggest opportunities in the global energy transition. It's already a $250 billion market, and analysts say it could reach up to $12 trillion in the decades ahead. Hi, I'm Steve Hill, CEO of NewHydrogen, here today to share a recent breakthrough by our technical team. But first, you might be wondering how clean hydrogen can become a $12 trillion market opportunity. Hydrogen is important to modern life, and we can't live without it. Hydrogen is the key ingredient in making fertilizers needed to grow food for the world. It's also used for transportation, refining oil, and making steel, glass, pharmaceuticals, and much more. To meet this market need, NewHydrogen is developing Thermaloop, a breakthrough technology that uses water and heat instead of electricity to produce the world's cheapest clean hydrogen. Water is abundant and covers more than 70% of the Earth's surface. But what about the heat needed to power Thermaloop? It will require a massive amount of heat to meet the worldwide demand for clean hydrogen. Now to our big news. Our technical team has confirmed that the massive heat generated by current and future power plants can directly drive the Thermaloop process. This is a huge opportunity. Let's turn to Eric McFarland, our Chief Technology Officer, to learn more.
In power plants and large industrial production facilities, high-temperature heat sources are required. In coal, gas, or nuclear power plants, heat is first produced from combustion or fission and then converted to electricity by mechanical turbine generators at relatively low efficiency. The Thermaloop process requires high-temperature heat, which could come from the use of electricity. However, heat is much less costly than electricity, and by coupling directly to the heat from power plants and chemical process furnaces, an integrated Thermaloop process uses the heat to produce hydrogen and minimizes the need for any electricity. With minimal electricity use together with a comparatively low capital cost, thermochemical hydrogen production with the Thermaloop process overcomes the practical limitations of existing electrolyzer technology. Today, there are 2,500 coal plants, 4,500 gas plants, and 440 nuclear plants operating around the world. There are currently 70 nuclear power plants under construction and 150 new reactors are planned, expecting to provide over 500 gigawatts of power by 2030. Significantly increasing the role of zero CO2 electricity from nuclear power is the only realistic way we can provide low-emission, reliable electricity at large scale to power modern cities, data centers, and the increasing power demand from artificial intelligence. We see this new breed of small modular reactors as becoming increasingly important. They will become a low-cost, constant source of high-temperature heat that we can use to make large-scale clean hydrogen a reality.
Thanks, Eric. During a recent CNBC interview, United States Energy Secretary Chris Wright addressed our immediate need for more power.
We think we need to add 100 gigawatts of new firm capacity in the next 5 years.
Secretary Wright also announced that the United States will add 300 gigawatts of new nuclear capacity by 2050, primarily through the deployment of small modular reactors. These SMRs range from about 30 to 1,000 megawatts of thermal energy and are designed for distributed power generation to serve data centers, cities, and even regions. Even Google has taken notice. In 2024, they signed the world's first SMR power purchase agreement for up to 500 megawatts, with the first 50-megawatt plant sited in Oak Ridge, Tennessee. Our technical team recently completed preliminary design and economic studies for integrating Thermaloop with current and future power plants. The team concluded that power plants are an ideal source of constant and reliable baseload heat for Thermaloop. Power plants produce constant high-temperature heat and high-temperature steam, two key ingredients needed for Thermaloop to make the world's cheapest clean hydrogen. Thermaloop can even be retrofitted into existing power plants or integrated with new SMRs to create dedicated clean hydrogen production plants. Let's go to Sundar Narayanan, our Director of Process Engineering and former ExxonMobil technologist, to learn how Thermaloop can couple with small modular reactors and other power plants.
The NewHydrogen team is screening promising thermochemical water splitting process concepts by combining its unique expertise in the discovery and design of materials for facilitating water splitting reactions, nuclear engineering, and chemical process development. We are designing the Thermaloop process to optimally integrate with SMRs, other utility-scale power plants, and high-temperature industrial processes to reduce the cost of thermal energy used for water splitting, consistent with our techno-economic goals for clean hydrogen production at commercial scale.
Thanks, Sundar. Hydrogen does things electricity cannot. It can be stored in bulk, transported long distances, and used in industries that are some of the hardest to decarbonize, like steel, cement, fertilizers, aviation, and shipping. By producing hydrogen, new small modular reactors could expand their role far beyond power generation and into these massive industrial and transportation markets. We've already demonstrated our thermal loop system producing hydrogen continuously using only heat and water in a looping thermochemical reaction. No electricity, no fossil fuels. Now we're refining the chemistry and materials and collecting the data required to scale to larger units. Thermal loop is designed to operate in the same temperature ranges that small modular reactors deliver, which makes it a natural complement. To give you an idea, a small 50 megawatt SMR, coupled with thermal loop, could potentially produce about 54 metric tons of hydrogen per day, enough to fuel 54 standard one-ton hydrogen fueling stations, handling 10,000 hydrogen-fueled passenger vehicle fill-ups per day. That's the kind of scale and reliability needed to enable a true hydrogen economy. Many power plants, new or existing anywhere in the world, could integrate with thermal loop to enable around-the-clock, dedicated production or cogeneration of clean hydrogen. We believe this alignment is powerful. Small modular reactors are on track to provide steady, high-temperature heat, and our technical team has confirmed that thermal loop can transform that heat directly into clean hydrogen. Together, they can open the door to large-scale hydrogen production at costs the world has never seen before. That's not only a step forward for energy security and decarbonization, but it also taps into what Goldman Sachs has described as a nearly $12 trillion global hydrogen market. For reactor developers and power plant operators, this is an opportunity to expand beyond electricity and into a new energy economy. We look forward to continuing these conversations and collaborating with others to help move thermal loop closer to the marketplace.